Alright, the final thing we have to do is graphing. When we are graphing, we basically need to link everything together that we've already discussed. So we need to know where the graph starts and ends. Remember that this is called the end behavior, and it's based on the degree and the leading coefficient of the polynomial. We also need to know the y-intercept. Remember that the y-intercept is found by looking at the constant. The x-intercepts are found by factoring, so you will have to factor this out. And then we also need to know something about the multiplicity of each factor, which is examining the degree of each factor. This is something new, so let's take a look at what that means. Okay, so multiplicity basically means the power on a factor. So if there's only one of each factor, it's going to act like a line, because the power of 1 represents something linear. So here, at each x-intercept, it's going to pass straight through just like a line. So again, if it's a power of 1, or if there's only one of each factor, it's going to pass nicely through like a line. In this case, there would be 2 of this factor. The reason I know it's 2 is because a parabola is being made at that x-intercept. So again, a parabola is a degree 2, which means there would be 2 factors at that spot. So again, let's say that this was at 2. That means that you would have an x minus 2 squared as your factors. So anytime you see 2 factors, you're going to get a parabola. If you see a multiplicity of 3, so in this case, let's say that this is at 1. So let's say you had x minus 1 cubed. Anytime it's a cubic function, we call it tangent to and crosses. So tangent to means that it flattens, and then crosses and it passes through. So it's making this little shape where it levels out and then passes through. So that's if it's multiplicity 3, it's going to go tangent to and then cross through. So it makes that little bit of a wave on its way through. Alright, so here in example 1, we are going to, without using technology, sketch the graph of this polynomial. So this is already in factored form. To find the degree, remember we need to add the powers up. So there'd be x cubed here, and then x to the power of 1 here, which means our degree in total would be 4. 3 x's in the first set of factors and 1 in the next, so degree 4. Remember that the leading coefficient comes from looking at your front numbers. So here the front numbers would just be a 1, because I have a 1x and just a 1x. So my leading coefficient is 1.
And we'd multiply those?
So if it is a degree 4 and a leading coefficient of 1, that means it'll start at 2 and end in 1. So we say quadrant 2 to quadrant 1. Again, because it's like a parabola that's opening up. So it's going to start at 2 and end in 1. Now we can go and find the zeros or the x-intercepts. How do you always find an x-intercept?
Make the brackets equal 0.
Make y 0. So if I make the y value 0, that means that one of my x-intercepts is at 2, and the other x-intercept would be at negative 1. So I'm going to have an x-intercept at 2 and an x-intercept at negative 1. So let's also find the multiplicity at these x-intercepts. So I see here at the x-intercept of 2, there's a multiplicity of 3. So there's a power of 3. So I'm going to just put here, I'm just going to draw an arrow if that's okay. The multiplicity is 3. And at the negative 1, the multiplicity is just 1. So remember that that means that at the x-intercept of positive 2, we're going to make like a cubic and go tangent 2 before crossing through. At the x-intercept of minus 1, we're going to act like a line and just pass straight through. Now the final thing is our y-intercept. Now in factored form, you have to do a little more work for the y-intercept. How do you always find a y-intercept? Set x to 0, yeah? So to find my y-intercept, I'm going to put 0 in for my x's. So y equals 0 minus 2 cubed, and then 0 plus 1 to the power of 1. So minus 2 cubed is going to be minus 8 times 1, which is going to be minus 8. So my y-intercept, again, is minus 8 when I plug in 0 for x. Same process as always, plug in 0 for x to find y. Alright, so then it's time to make the graph. So when we're making the graph, we have to put all of our information on here first, and then we're going to go through and connect the dots. So I know my y-intercept is at -8, so I'm going to put a y-intercept at -8. I have x-intercepts at 2 and at -1, so I'm going to put those points on as well. Now, what we do with our pen then is we have to start our pen in quadrant 2, because I know my graph starts in 2 and ends in 1. So you're just going to put your pen in quadrant 2, and you're going to head toward the -1, 0, or the -1 x-intercept, okay? As you head toward the -1 x-intercept, remember that it's a multiplicity of 1, so your pencil is going to cross straight through the -1. I'm just going to start somewhere up here, and I'm going to pass straight through the -1, all the way down to that y-intercept, and then I'm going to have to curve back around, because I need to come back to that +2 x-intercept. When I get to the +2 x-intercept, I see that I have a multiplicity of 3, so I need to level out before crossing through it. So I'm going to kind of level out, and then cross through it, something like that. And then just finish your graph with arrows. Okay, so we're going to start then with our first graph here. Let's take a look at the possible degree. So remember that the possible degree is based off of your x-intercepts. So here I have 3 x-intercepts, and each x-intercept has a multiplicity of 1, because the graph passes straight through at each one of those x-intercepts. So if there's 3 x-intercepts, all multiplicity of 1, that means my degree is 3. Let's look then at the leading coefficient sign. So is it positive or negative? So let's see, as we're starting down here in quadrant 3 and ending in quadrant 1, that would be like an upwards line. So we're going to say that that is a positive leading coefficient. Now the end behavior, again, we already looked at that. It goes from 3 to 1, quadrant 3 to quadrant 1. And let's look at the x-intercepts. So the x-intercepts, I see that I have one here at -4. I have one here at -2. And one here at +2. So I have 3 x-intercepts, and they're all given in the graph. Let's also look at what the multiplicity is of each of those. So again, the multiplicity, we can see that our graph passes just straight through at each one of those, which means they're all multiplicities of 1. So I'm just going to put 1s underneath. I hope that makes sense. I'm saying that the -4 x-intercept has a multiplicity of 1, so does the -2, so does the 2. Now the y-intercept on here, it actually is right there. It's above the -20, and it's a little hard to see, but it is at -16. So that would just be given on your graph, -16. Now this is something new. Okay, we're going to talk about positive intervals and negative intervals. What a positive interval means is that your graph is above the x-axis. So positive means above, so just try to squeeze that in there somewhere. Positive means above, negative means below the x-axis. So positive is above, negative is below. So with the interval notation, we're looking for where the graph is positive or above the x-axis and where it's negative or below. So I did in blue here where the graph is positive. So here we'd say it's positive between -4 and -2. And then we're going to put a u in between. The u means and. So and this other section over here, which is from 2 to infinity. So we have 2 sections of positive blue graph. We also have 2 sections of negative green graph. So the first section of negatives is from -infinity to -4, and then the next section of negative graph is from -2 to +2. So again, we link them with a u because the u means and. So -infinity to -4 and -2 to +2. Please pause the video here and try the next side on your own. Alright, so just check your answers with those on the board. Now we're going to go on to example 3, and we're going to graph these polynomials. I will graph the first one with you, and then we'll try the next couple on our own. So let's start with A. Before we start this, we have to find all of our information. Okay? Let's start by finding the degree. So once you have your degree of 3, your leading coefficient of 1, that means your end behavior is 3 to 1. I always write this on my graph. So I'd always put 3 and 1. So I know that my pencil has to start in 3 and end in 1. Then we're going to put our x-intercepts. Our x-intercepts are 1, -2, and -3, and my y-intercept is down at -6. Remember that you cannot have any more intercepts than the ones you found. You can't magically create more as you draw your graph, right? So all of these are at multiplicity of 1, which means I'm going to pass straight through all of them. So start down in quadrant 3. You're going to pass straight through the first one, turn around, pass straight through the next one, go down to that y-intercept, and go straight through the last one. So it's going to look something like this. One more thing to notice is that the larger the gap between the x-intercepts, then the higher the bump would be. Okay? So here, there's not very much space between x-intercepts, so it's just a little bump. Here there's a bigger space, so it would be a bigger bump. Also remember here that your vertex of this section would be kind of halfway between the two values, the two x-intercepts that you have. So it should be, the vertex would be down here, and then it comes back up through -6. So for part B, you can try this on your own, have a look, and you should find that all of your information matches up with this graph. As well, here we have graph C. So again, this one though was in polynomial form, so you had to start by factoring it. And then once you've got it factored, again, you should be able to draw your graph. We're going to then move on to these textbook questions on page 147.